So today we are going to analyze a very great topic in mathematics, which is standard form. Now I know the topic may look challenging because we've actually gone through indices and a part of logarithm together. So it will be a very great topic, an interesting one indeed. Just do well to listen to me while I talk on this topic, and yes, give me all your necessary attention. So we have what we call standard form, and we have what we call ordinary form. Now, there are some cases where the numbers are just too many. And when the numbers are just too many, we find it so hard to group these numbers so that it can be very easy for us to analyze. So that's where the need for standard form comes into play. Now, we should have an easier way to express our numbers in this form, which is a times 10 raised to power n. So we are expressing our number in the form of a times 10 raised to power n, where a is usually less than 10. Less than 10. So a is usually less than 10. So we cannot have 10 times 10 raised to power n. No, it is not advisable. All we want to see is from 1 to 8. We want to see from 1 to 9. Let's say from 1 to 9. 1 to 9 is fine. But we don't want to see 0.8 times 10 raised to power something. We don't want to see 10 point something or 11 point something or 20 point something. No, what we want to see is from 1 to 9. And these things would actually be in form of decimal. So maybe 1.2 times 10 raised to power something, or 2.3 times 10 raised to power something, 10.5 times 10 raised to power something. All that has to do with standard form. Then also this n you see here, this n you see here is our power. And the power will depend on whether the zeros you are moving it forward or whether you are moving it backwards. Now I will explain again. Remember, in indices I said that when you have 10 raised to power minus a is equal to 1 over 10 raised to power a. So meaning that if we're having a 10 raised to power minus a or 10 raised to power minus 1, meaning that it is somehow 0 point something. So if we say 0.8 now, this is already moving the zero backward. You understand? Moving the decimal point backward. And this already implies that it's a negative sign. It's a negative sign. But in a situation where it is 10 raised to power 1, you know that you are multiplying it by 10. 10 raised to power 2 multiplied by 100. 10 raised to power 3 multiplying it by 1000. So whenever you have a negative sign, you know that you are moving it backward. But whenever you're having a positive sign, you are moving it forward. So we are going to analyze some questions together. You know, all these things are theoretical. Until we start with practicals, we start seeing the value of all these things. So we have a first example, which is 89142. Now convert this to standard form. Now, in converting to standard form, you have to understand that there is an invisible decimal point here. So meaning that if you have 8 is 8.0. Do you know that 8 is 8.0? Now you know today. So 8 is 8.0. So meaning that if we have 89,142, we are converting it to standard form. It therefore means that there's a decimal point here. And you move the decimal points 1, 2, 3, 4. So it's going to stop here because I told you that it has to be less than 10. So 8.9 is less than 10. So we'll now come here and say 8.9142 times, how many times are we moving? 1, 2, 3, 4 times 10 raised to power 4 times 10 raised to power 4, because we moved our decimal point 4 times. In a situation where we have something like this, 8.8914, and the decimal point is here, you know we're going to move it 1, 2, 3. So this will be 8.914 times 10 raised to the power 3. We follow. So if it is 891 now, we're moving our decimal point from here 1 2. So this will give us 8.91 times 10 raised to the power 2, because we moved our decimal point 2 times. Then we have 0.8914. In this case, we are moving our decimal point forward to get to this place. So this will give us 8.914 times 10 raised to the power minus 1, because we move our decimal point towards this direction. It's supposed to go backward, right? So in this situation, we have 0.00821. We're moving it 1 2 3. So this becomes 8.21 times 10 raised to the power 1 2 3 minus 3. Or maybe we have something like this, 0.00621. We move it 1 2 3, which is 6.21 times 10 raised to the power minus 3. Because of this negative signs here, because of this 1 2 3, because of the 0.00. And also something I told my students as well too is, when the 0 is here like this, it is significant. But when the zeros are here like this, 821.00, the zeros here are insignificant. But just add one number now, it becomes significant. Remove this one now, it becomes insignificant. Or just add 1 or 2 here, these zeros become significant. So where the zeros are depends on whether it's going to be significant or whether it's going to be insignificant. Ensure that you understand these points very well. And also I will show you some other things as well too in this aspect. So try to understand this very well. So in a situation where we have something like 8.914 times 10 raised to the power 3, they now tell you convert this to ordinary form. How will you go about this? Now we'll write this 8.914, because I usually show my students this method. We write times 10 raised to the power 3. Now I believe you know that 10 raised to the power 3 is 1000. So you remove this 10 raised to the power 3 and write 1000. Now we are going to be moving our decimal point. Cancel 1 0, you move it 1, cancel another 0, move it forward, and cancel the last 0, you move it to this point. And when you move it to this point, it means that there's an invisible decimal point here, which implies that our final answer is going to be 8,914. That's what we are final answer. So if we are converting this to ordinary form, it is 8914. Okay, so for example, we have something like this, 8.914 times 10 raised to the power minus 1. 10 raised to the power minus 1, or let's say 10 raised to the power minus 4. For this situation, just write your 8.914 here. Then now write times 10 raised to the power minus 4. 10 raised to the power minus 4, you remember, using laws of indices, 10 raised to the power minus 4 will become 1 over 10 raised to the power 4. And 10 raised to the power 4 is 1 over 10,000. Because you know this is 1, 2, 3, 4. So 1 over 10,000. So we are going to do this way. We are going to move our decimal points. We'll cancel 1 0. We move it backward. Cancel another 0. You write to 0 here. You move it backward. Cancel another 0. Move it backward, cancel the last 0, okay, decimal point here. So now if you put your decimal point here, you know that there's an invisible 0 here. It's 0.008914. So this therefore implies that our answer will be 0.00089114. The perfect way to really analyze this is to come here and check it out if it's correct. 1 2 3 4. So this is giving us 8.914 times 10 to the power minus 4, and that's our final answer to this particular question. So possibly, I do believe that you now understand this, I'll also give one more example, one last example for this aspect, so we can easily analyze this for all those that are finding it difficult to take note of this. So we have another example. Let's say we have 60 to 6,000. They convert this to standard form. Remember that there's an invisible decimal point here. Take it backward: 1, 2, 3, 4. So we have 6.214 times 10 raised to the power 4. 1, 2, 3, 4. Following. You don't need to add this 0 because this 0 is insignificant. Let's try something like this. So move it 1, 2, 3, 4, 5, which is 6.8826 times 10 raised to the power 5. So that is it for now, and this just makes us to close chapter of standard form. If you have any question, feel free to ask me in the comment section.